do you tell which fraction is bigger when compared with another one? Two fractions are kept side by side and you are told to tell which one is bigger and which one is smaller. How do you tell which one is bigger and which one is smaller? Take for instance, you have 2 over 3 and 3 over 4 and you are told to tell which one is bigger and which one is smaller. How do you go about saying which one is bigger and which one is smaller? Is it even true that one is more than the other one in magnitude? Is any of them bigger than the other? Certainly, fractions can be bigger or smaller than other fractions. But how do you tell? Granted, 3 is bigger than 2. But in this case, we are not comparing 2 and 3. We are comparing 2 over 3 and 3 over 4. So how do you tell which one is bigger of these two fractions? That takes us to lesson objective number 10, and that is order of fractions. In this section, we learn how to tell which fraction is bigger than the other. Please follow me as I explain step by step how to tell which fraction is bigger than the other. In this section, we learn order of fractions. What is order of fractions? From this word order, we sense that we are going to learn arrangement of fractions. In this section, we learn how to arrange fractions according to their magnitudes. It is natural to compare two numbers with view to knowing which one is bigger or smaller. It is not a difficult thing to tell which one is bigger or smaller between 1 and 2. But look at this array of fractions. 4 fractions. 3 over 4, 11 over 12, 5 over 6, 1 over 2. Which of these fractions do you think is the highest in magnitude? That is the biggest in size. Or do you think that all the 4 fractions are the same in size? Certainly, no. Therefore, we should tell which one is the smallest, followed by which one, followed by which one, and which one is therefore the biggest or the highest in magnitude. We seek to arrange these 4 fractions in order of their magnitudes. We either arrange them in ascending order or descending order. In ascending order, we start with a fraction that has the smallest magnitude and move up to that has the highest magnitude. If we choose to arrange them in descending order, what we do is to start with the fraction that has the highest magnitude and keep writing the others until the last one is that has the lowest or smallest magnitude. Either way, we should first know which of these fractions is bigger than the other. Only then we will know how to arrange them either in ascending order or descending order. Again, how do we know which of these fractions is the biggest and which one is the highest? What do you even think is making it difficult to tell which one is bigger? Please compare these 4 fractions we want to look at with what I want to write next. Please compare it with what you see next. Please compare these 4 fractions with these 4. Let us assume that we want to arrange these ones, and we also want to arrange these ones. Which of these 2 sets of fractions do you think will be easier to arrange? Obviously, this second set is easier to arrange. Why? Let us interpret each of these fractions and afterwards decide why it is easier to arrange them. than it is to arrange this first set. 2 over 7 means 2 picked out of 7. 1 over 7 means 5 picked out of the same 7. 5 over 7 means 5 picked out of the same 7. 3 over 7 means 3 picked out of the same 7. I do not mean that all of these 2, 1, 5, 3 are at the same time picked out of 7. I'm only saying, what if something is broken into 7 and somebody is to pick 2? Okay, what if he does not have to pick 2, but what he should pick is 1 out of 7? What if he drops picking 1 out of 7 and he is told instead to pick 5 out of 7? What if he is told not to pick 5 out of 7, but to pick 3 out of 7? Which of these 4 possible pickings do you think will give him the highest magnitude of portions? So with this, you have come to know that I don't mean that 2, 1, 5, 3 are picked all the same time from 7. That will be impossible. It is impossible to pick 2, 1, that is 3 now, 5, that is 8, plus 2, that is plus 3, that's 11. We can't pick 11 out of 7. That is impossible. So know it that I simply mean possibilities, chances of picking portions out of 7. If not this, let it be this. If not this, let it be this. If not this, let it be this one. Which of these options do you think would have been the highest in magnitude? That is the point we're trying to make here. Okay, now back to it. Why is it easy to arrange these ones, but not this? The answer is that each of these portions was picked out of the same 7. Because it is assumed that 2 are picked out of the same 7 that 1 is to be picked out of. What it means is that it is now easy to compare these 2 and 1, which means any number of portions you pick comes from that same 7, which means each portion is equal to other portions. So somebody who picks 2 out of 7, if you compare the size with what you pick, if you are told to pick, or the person is told to pick 1 out of 7, will conclude that 2 out of 7 is bigger in size than 1 out of 7. Therefore, from that angle, we'll conclude that if the person is allowed to pick 5 out of 7, he would have picked the highest of the magnitudes, and then next to it is 3 over 7, and then next is 2 over 7, and the smallest is 1 out of 7. Based on that, we can quickly arrange these fractions in either ascending order or descending order of magnitudes. Let me arrange the fractions in ascending order of magnitudes. Please watch as that happens. And here they are. In ascending order, 1 over 7 is less than 2 over 7, which is less than 3 over 7, and 3 over 7 is less than 5 over 7, which means 5 over 7 is the highest of all. From the smallest to the largest, we've arranged these 4 fractions in ascending order. Again, I ask, why was it easy to arrange these fractions? The answer is that each of the fractions, each of the portions was picked out of the same 7 portions. Therefore, it is easy to arrange fractions that possess the same denominator. What about these ones? Why is it now difficult to arrange them? The answer is that each of these portions was picked from different numbers that correspond to denominators. This one has 4, this one has 12, this one has 6, this has 2 as denominator. What it means is that it won't be as easy as this one was to arrange. What then if we insist on arranging these fractions? The only way is to make all these fractions possess the same denominator. Is it possible to do that? Surely it is. Why? Because we should recall what happened at the time we discussed equivalent fractions. We can just look at 4, 12, 6, and 2, and then take one of their common multiples. 4, 12, 6, and 2 have common multiples. This is not the time to begin to list their common multiples. We can do it without listing them physically. Mentally, we can agree that 4, 12, 6, and 2 have 24 as the list of their common multiples. Therefore, we are going to convert this fraction to something over 24. This one too, something over 24. This one also, something over 24. Also this one, something over 24. Please, follow me as I convert each of these fractions to something over 24. And here is how each of the numbers or the fractions was converted to something over 24. First, 3 over 4, see it here, converted to 18 over 24. I hope you know how that came to be. First, we ask, what is that makes this 4 become 24 by multiplication? It is 6, because 4 times 6 is 24. Therefore, this 6 is what multiplied 4 to give us 24. The same 6 must multiply 3, and that is why we have 3 times 6 here. Don't forget that if we want to get any fraction that is equal in value to the former, what you do is multiply both numerator and denominator by the same number. Here, the same 6 is multiplying numerator and denominator. So at last we have 18 over 24. It therefore means that 3 over 4 is equivalent to 18 over 24. This and this are just the same fraction, equal in value. They only differ in appearance. Next, we have 11 over 12. What is it that makes this 12 turn to 24? It is 2. That is, by multiplication, we say 12 times 2, see it here, to give us 24. It means that it is factor of 2 that multiplied 12 to give us 24. Consequently, the same 2 multiplies this 11. See it happening here. 11 times 2 is equal to 22, and then over 24. Therefore, 11 over 12 is equivalent to 22 over 24. I hope what is happening here is clear to you. Let's go on, please. The next is 5 over 6. How can this 6 become 24? It multiplies something to give us 24, and that number it multiplies should be 4. 6 times 4 is 24. This same factor of 4 should multiply this numerator, which is 5. Therefore, next we have 5 times 4 also, and that will give us 20 over 24. Therefore, 5 over 6 is equivalent to 20 over 24. The last but not the least is this 1 over 2. I want to convert it to something over 24. That means that this 2 should become 24 by multiplication. Please, in that way, what makes 2 turn to 24 by multiplication? It is this 12. 2 times 12 is 24. Therefore, the same 12 multiplies the numerator, which is this 1, giving rise to 1 times 12. And that will give us 12 over 24. Therefore, 1 over 2 is equivalent to 12 over 24. I hope that is clear to you. Let us now make statements of correspondence between this arrangement, this array of fractions, and these ones we have here. And here comes the statement of correspondence. 3 over 4 corresponds to 18 over 24. 11 over 12 corresponds to 22 over 24. 5 over 6 corresponds to 20 over 24. 1 over 2 corresponds to 12 over 24. Now, can we arrange these ones? Is it not possible to arrange these ones? If we arrange these ones, we have in style arranged these ones. Now we know why we have to change each of these fractions to something over 24. It is because before now, we agreed by means of this exercise that it is easy enough to compare fractions that possess the same denominator. Now, all these fractions have come to possess the same denominator, so it has become easy to order them. Please permit me to arrange these 4 fractions in ascending order. Please watch out. Now, behold the ascending order of these 4 fractions. You agree with me that the smallest of these fractions is this one, followed by this, and the highest is this one. That is why, in ascending order, 12 over 24 is the first. It is less than 18 over 24, which in turn is less than 20 over 24, which is in turn less than 22 over 24, which is the highest in this case. Because we have arranged these fractions in this order, we can as well arrange the apparent fractions in ascending order. Since this corresponds to which one, please? This 12 over 24, which is here, corresponds to 1 over 2. This 18 over 24 corresponds to this. This 20 over 24 corresponds to 5 over 6. This 22 over 24 corresponds to 11 over 12. Based on this, find the arrangement of these 4 fractions in ascending order of magnitudes. Please watch out. Now, finally, you can see the arrangement of these 4 fractions in ascending order. Because of this arrangement, we conclude that 1 over 2 is less than 3 over 4, and 3 over 4 is less than 5 over 6, and 5 over 6 is less than 11 over 12. If it is order different from this ascending order you want to make use of, that is descending order, all you should do is to start with this 11 over 12 and write it up to 1 over 2. But by then, is either use comma or a symbol which is more than. It is believed that all I have said in this section is clear. This one example is just sufficient. Arranging fractions in order of magnitude is not challenging. The main thing is just having known what is equivalent fractions and how to obtain them. We apply same in doing this business of arranging fractions according to their magnitudes. All right, please, having done this, let us check if we have understood what has been said here. Watch out for an exercise. And here comes the checkpoint. It says arrange each of the following collections of fractions in A, ascending order, B, descending order of magnitudes. Number 1, 3 over 4, 11 over 12, 5 over 6, 4 over 9. Number 2, 5 over 6, 1 over 4, 2 over 3, 5 over 8. Number 3, 5 over 18, 1 over 6, 7 over 9, 1 over 3. Number 4, 1 over 2, 2 over 5, 2 over 3, 14 over 15, and 5 over 6.